Hello everyone. We're going to be continuing on discrete random variables, and this time we're going to focus on binomial random variables. The topics I'll be covering: first, I'll be doing a recap of the random variables. Then in this I'm going to talk about a definition, an example, and a probability distribution. Then finally, the main topic in this session is binomial random variables. We're going to look at an example, some mean and standard deviation, and then some more examples on binomial random variables. So let's start with what is a random variable. A random variable is a quantitative variable whose value depends upon chance. Okay. Remember, it's a variable. Variable means a characteristic of a population or a sample we're looking at. And its value will depend upon chance. And this randomness which is coming in this word random variable, this is coming from selecting a random sample for a population or performing a randomized experiment. And we use a random variable to model the behavior of populations. The notation here is we will be using capital letters to represent a random variable and a lowercase letter for all possible values. So an example would be done in the next slide. One more thing here. There are two types of random variable. One is called the discrete and the other is the continuous. So this session we are focusing on an example of a discrete random variable called the binomial random variable. So let's do a quick recap of a random variable example. And I will equate it once again to the things we have learned earlier and why random variables are very important for us. Okay, let's look at a sample space. And this is a sample space for a flipping of a coin 3 times. So basically we're going to flip a fair coin 3 times. I'd like to know what are the all possible outcomes in this sample space of flipping a coin. So notice we will have all the flips we do, the 3 flips, every time we get is a head, or we can have a head, head, and a tail, head, tail, head, and a tail, head, head. So these 3 basically are constituting towards the 2 heads. Then we can have a scenario where we can have 2 tails and a head, or a tail, head, and a tail, a head, tail, and a tail. So these 3, the tail, tail, head, and tail, and head, tail, tail is contributing towards 1 head. And finally, a scenario where there is no heads. Now, this was easy because it's only flipping a coin 3 times. Now, suppose we had to flip a coin 10 times. Would you like to write the sample space? Well, I would not. So what are we going to do is we say, is there another way of writing the sample space and every information is given about it? So let's look at that. So what you're going to say is, let's pick up a variable. Variable is a one characteristic, and we're going to pick up a random variable. And the reason it is a random variable, because when you flip a coin, you may or may not get a head. So that's the randomness you're getting. So what we're going to do is we're going to say, let's look at a random variable, capital X, which represents the number of heads in 3 flips of a coin. Okay, now this X, so every time I flip, so these are number of heads. Now the key part, guys, is the number of heads. So what are the possible values your capital X can take? And it's the number. So your capital X here and is equal to little x. Now this little x can be, so this x, little x can be 3, this little x can be 2, this little x is 1 or 0. Now remember, when I say little x equals 3, the underlying concept is that the number of heads, when I flip 3 times a coin, I will get only heads. Okay, so the number of heads is 3 times the head is appearing. Now when you look at the sample space where we literally wrote it down, so I'm going to use a green pen here. So this triple H is basically representing this value for the random variable. On the other hand, when I say 2 times the head appears when you have 3 flips. So these are 3 possible scenarios. The blue pen, color over here represents x equal 2. Then when you flip a coin 3 times again and you only get a 1-time head, so these 3 scenarios are being represented by x equals 1. And finally, when there is no head appearing, so what we notice is this head, this x equals 0, is basically representing by the 3 t's. So all these sample space is written in such a short form, which is captured by this x. And that's the beauty of a random variables. In a very short form, we can represent many of these outcomes of a sample space. This is just one simple example. Okay, also notice that this random variable that has a probability distribution, and I'm going to come back over here. I'm just going to look at the information here. So this probability distribution or distribution of a random variable. Now, when you looked at the previous example, what did we find? That this random variable was being represented, but what are the values my x can take? So all possible values my x can take is being represented by this random variable. Not only that, when I talk of a probability distribution, what I'm saying over here is, what is the probabilities each of these possible values can take? So when you combine these two together, that is all possible values of x and the probabilities these possible values can take, we are saying, or we are talking about a probability distribution of a random variable. Now, I do not want to say so many terms, probability distribution. I'm going to say, hey, distribution. So the moment you hear the word distribution of a random variable, in your mind, we are looking at all possible values of x and what are the probabilities these possible values can take. So going back to our example where my x is the number of heads in 3 flips of a coin. So what were the values you had? We had x to be either 3, 2, 1, and 0. Now we'd like to know the probabilities that x is x. So let's quickly write this down and you will have an idea. So we have, this is the sample space I'm writing down, guys. Okay. Okay, notice when I say there are 3 heads in 3 flips of a coin. So what am I talking about? This event. Only one possible scenario. So what is the probability of 3 heads to happen when 3 flips of a coin? One possibility. So the probability is the favorable events divided by the total number of events. Now when it is 2, so 2 means what? There are 3 possible scenarios. So this one is 3/8. Now only one head is appearing. So we are looking at the next 3 here, and these are, the probability is again 3/8. And when not a single head appears, that means we're looking at one possible scenario, all t's, 1/8. Okay, now we're going to look at a connection between things we did in probabilities. They're exactly happening here too. Notice here, the first thing is that for every possible value this random variable can take, the probability falls between 0 and 1. Look at the probability, 1/8, 3/8. And each of this probability is a decimal, and it's a proper decimal. It lies between 0 and 1. The other part is, which is very true, that the sum of all these probabilities of all possible values, basically you're looking at the whole sample space, is 1, which is this. The sum of the probabilities of all possible values equals x. So basically add these to 1. So let's look at this one, and we're going to get this here. And when you see this part, notice what is it? This simply means probability. Okay, let me write it down in the proper notation. The sum of these probabilities, guys. The sum of all these probabilities, the way we write it nicely, in a very short form, probability of all x values, which is basically the probability when x is 0, when x is 0, plus x is 1, plus x is 2, plus x is 3. Notice when you add this, what do you get? You have 1/8 plus 3/8 plus 3/8 plus 1/8, which is 8/8, which is a 1. And that's a very, very important part. The sum is always going to equal 1. Now, these distributions, guys, which we are talking about are the probability distributions. We can represent them as a list, a chart, a graph, frequency table, relative frequency table, or even mathematical functions. So here, when we're representing this probability distribution of a random variable, it's like a table. Okay. Now, let's talk about a very special kind of a distribution. And this distribution is binomial. Now, look at the word bi. Bi means 2. How is it connected to what we are looking at? It simply means that when we are looking at an observation, for example, if I flip a coin, what happens? There are only 2 possible outcomes. I'm either going to get a head or we're going to get a tail. Okay. Now, let's look at if you have to answer a question. And if you would look at how many points you can get. The number of points you can get in a question is if your question is correct or your question is incorrect. So once again, the number of correct answers in a quiz is always going to be, there are only 2 possible choices for every question. Either it is correct or not correct. So those are the scenarios whenever you're looking at a problem where every observation has 2 possible outcomes. That is what we are going to have in binomial probabilities. So I'm just going to go over the questions here, which I just briefly talked about in this slide. So here it is the formal expression. When we're looking at some different binomial random variables, so the number of correct guesses at a 20 true-false question, or the number of heads when you flip a coin 10 times, the number of customers who prefer lattes to cappuccino in a random sample of 50 Starbucks customers. So in every scenario, notice there's only possible 2 outcomes for any observation. So in the first one, when you are looking at number of correct guesses, so if you're answering a question, say multiple choice quiz or a true-false question, so your guess can be either give you a right answer or it's going to give you a wrong answer. Now, if you're going to buy, you're looking at, so suppose you're a store manager of a Starbucks and you say, okay, how many customers are preferring lattes to cappuccinos? So every time you pick up a random customer and you see their choice between these 2, so once again, there are only 2 choices. And similarly, when you flip a coin, only two choices will happen, either a head or not a head. Okay, so in all these scenarios, there are very important common characteristics we're going to talk about. What we noticed in these examples was that every random trial, that every time we conducted an experiment, there were fixed number of trials. For example, when we flipped a coin, how many times you flipped? 10. So when you're looking at the number of correct guesses in a question answer, true-false scenario, how many questions the person had to guess? 20. Now, if you're looking at in terms of preference of coffee, of like whether it's latte or a cappuccino, again, how many customers were randomly picked? 50. So the number of trials is fixed. Now, every trial, the event of interest, depending upon what we think as an interest, is there a success or a failure? That means two possible outcomes. Simple words, guys, this is two possible outcomes. Okay, now every trial has the equal probability of success. For example, when you guess a question and it's a true-false, so what is the probability of getting a success in a true-false? If there are only two possible choices, so the probability of success here is 0.5 because it's half. Similarly, when you're flipping a coin, what is the probability of success? Probability of success depending upon what you're looking as an event. Or say if you're looking as a head, what's the probability of getting a head? 1.5. That's what it says. And the outcome of each trial, so every time is independent. What it means is that every time you are flipping a coin, say, so when you flip the coin first time and when you flip the coin second time, there is no kind of effect of the first flipping to the second flip. That's the meaning that the trials are independent. So now we're going to go and define what is a binomial random variable. A random variable, which has the above four characteristics, has a binomial distribution. Now, suppose we have a binomial distribution. How do we represent? The convention is to write it in this form. We write x, little tilde here, or whatever you want to call it. It says binomial. B is representing, the capital B is representing binomial. And the two parameters, the n represents the number of fixed trials, and this little small p represents the probability of success in each trial. So every time you have a probability distribution which is binomial, those will always be represented in two parameters. One is n, one is that is number of trials, the other is the probability of success of every trial. And we'll be using calculator functions binom.pdf or binom.cdf to x less than equal to x or x equal to x, so binom.cdf, this is less than equal to x, so which is what we are going to use that, and I'm going to show you with the help of an example how do we do it. Okay, let's start with the example what we just talked about, the number of correct guesses for 20 true-false questions when you randomly guess them. How many trials? 20, so n is 20. Two possible outcomes, correct or incorrect. Every outcome is equally probable. That means p is 0.5. And every trial is independent because remember, the first question is not going to affect the second question answer. That's what it means. Okay, here's the formal definition of a binomial random variable. We say x is a binomial random variable with two parameters n and p if it models the number of successes that occur in n independent trials where each trial is a success with probability p and a failure with probability 1 minus p. So how do we find the formula here to this probability is n choose x, that's what it simply means, n choose x, p, that's the probability of success to the power x, and 1 minus p to the probability n minus x. This x is the possible values your random variable can take. Do not worry about these formulas, the n choose x, these are factorials. I just wanted you to have an idea of what a formula looks like. We are not going to be using this to solve our problems. What we'll be doing is using calculators. So make sure, guys, you have your calculators handy with you. Okay, let's start with examples now. In Math 1530 Statistics Multiple Choice Quiz, there are 4 questions, each with 5 possible answers. A student is going to pass the quiz if he or she gets a 60%. Now, one of the student Akis did not study for the quiz as he was being lazy. He still took the quiz and decided to guess at random for each question. Okay. Now, in this problem, guys, we need to know what is the random variable, what kind of random variable, is it binomial or not, and then we will proceed. So let's read the question again. It's a multiple choice quiz where there are 4 questions, each with 5 possible answers. And student is going to pass if he gets 60%. So, and a student, one of the students did not study. So he randomly takes the quiz. Now here's the question. Find the probability that he is lucky and gets all the 4 questions correct. So let's look at this one. All the 4 questions correct. So when you look at this problem, so the question is, our random variable is the number of correct questions. Okay, every question has 2 possible scenarios. So every question is either correct or incorrect. Okay, so that is the biggest clue. And the first sentence also says, what is the probability of correctness? That means out of the 5, only 1 possible scenario. So the probability of success is what? 1 out of 5, which is 0.2. And every question is independent. And there are 4 questions we have. So basically, it's a binomial random variable. So we say x has a binomial with n4 and probability of success 0.2. Now the question here is, what is the probability? Now this is a random variable. Now let's go a little bit further here. It's a random variable. What does that mean? As x is a random variable, that means this x can take some values. What are those possible values? So this little x can be, as there are 4 questions, all the 4 are correct, only 3 are correct, 2 are correct, 1 is correct, none is correct. Because it's a random variable, every random variable has a probability distribution. That means each of these x values will have a probability. And this probability is going to be a binomial probabilities here. So the question is, he gets all the 4 questions correct. Do you see this? All the 4 questions correct. Very lucky guy he is. So we want to find this. That's what the question. He guesses all the questions, and very lucky he gets all of them correct. Okay, so I want to find probability x is 4. Now, I've told you guys that we're going to use the calculator, but the formula is binom PDF. The number of parameters is 4. Probability of success 0.2, and what is the value we're looking is 4. Now to get this answer, I would like you guys to take your calculators out and we'll continue from there. So here's the calculator. How we do is, to get this binom PDF, you go second and then click on vars. So you see the distribution. Now take your cursor to, till you see the word binom PDF, that's here. Click enter. Now, how many trials? Now, remember there were 4 trials. That's 4 questions. Probability of success is 0.2. The x value we're looking at is 4. Then take the cursor to paste, press enter, enter. What do you see? Oops. Okay. So the answer is 0.0016. Okay, let's write that down. So the answer here is 0.0016. Okay, that's the answer to this question. Now let's move to the next part. It says find the probability that ACUS will pass the quiz. And according to the question, you pass the quiz when you get a 60%. So what is 60% of 4? Which is 0.6 times 4, which is 2.4. Now remember, your questions can't be a 2.4. So basically, the probability of this event that ACUS passes the quiz, that means ACUS passes quiz, simply means either he gets 3 questions right or he gets 4 questions right. That's the only possibility, which basically is this probability x is 3 or x is 4. Now, x is 4 we've already done in a previous session, in the previous slide, which is 0.0016. Now we want to find x equals 3. Now for this one, the formula is binom PDF 4, 0.2, and 3. Let's go ahead. Do the math once again, guys. So second inverse, take the cursor down to binom PDF, enter. Now everything's written down, so go to x value, change it to 3, paste, enter. It's 0.0256. So 0.0256 plus 0.0016. So what do we get the answer, guys, here? It's 0.0272. Okay, let's look at another question. A new restaurant is opening in Sparta Village. And this new restaurant has a 30% chance of survival during the first year. If in total 16 restaurants open this year, what is the probability that exactly 3 of these restaurants survived? Now keep in mind, guys, we have to make sure that what is the random variable we are looking at? Is it binomial? If it's going to be binomial, it has to satisfy those 4 characteristics. Okay, so let's look at this problem. Notice here that it's the main thing which you have to notice is what are the outcomes. And from their outcomes, we kind of go further. So how many outcomes? Is either the restaurant survives or does not survive. So our random variable is the number of restaurants that survived. So that's the number of restaurants that survived. There's only 2 possibles, whether either the restaurant will survive or not. So that is the biggest clue that it's a binomial. Now, what's the probability of success of this survival? So the probability, little p, the probability of success is what? 0.3. It's 30%. Now, how many restaurants had opened? There were 16. So, two possible outcomes, probability of success is the same, fixed number of trials. In every trial, that means every restaurant is independent here. Okay, so this X has a binomial distribution. Now we write it in terms of parameters. N is 16, P is 0.3. Now we've taken care of that. Now we go and look at what the question is asking here. It says, what is the probability that exactly 3 of them have survived? That means probability, this X is 3. So according to the formula, binom, PDF, 16, 0.3, and 3. Let's go get our calculators, guys. So second inverse, take the cursor to binom PDF, enter. Now the trials are now 16. Probability of success 0.3, the X value is the same. Then click on paste, take the cursor to paste and then click and then press enter. We get 0.1464. You know the other numbers, I'm just taking to 4 decimal places. 0.1464. Okay, let's talk about another example. We're going to look at eBay here. So the question is, you're bidding on 4 items which are available on eBay. You think that for each bid, you have a 25% chance of winning it, and the outcomes of the 4 bids are independent events. So let capital X is the number of winning bids out of the 4 items you bid on. Now the question is this a binomial distribution? Okay. And the very first important thing is, what are the outcomes of this bid? Because you're looking at the number of wins. So what we notice is that each bid, which is a trial here, results in 2 outcomes. And what are those 2 outcomes? Win or not win. Then each bid is independent. It is given to us. Each bid is independent. Okay. Then there are 4 bids, that is fixed number of trials. There are 4 bids. And the most important after the outcomes is the probability of success of each bid. The probability of each bid, that is the success of each bid winning, which is we're counting it as success, is 0.25. So yes, this can be modeled by the binomial distribution. It is true. Okay. Now let's look at the question. It says, find the probability that you win at least 1 bid. Okay, now let's look at this one. X has a binomial distribution with 4 fixed trials and probability of success is 0.25. Okay, now what are the possible values? Because it's a random variable, it's going to take some values. What are those values for X? So X can win all the 4 bids, win 3 bids, 2 bids, 1 bid, none of the bids. Okay, and the probability that capital X is X, so this X, guys, equal X, little x. Okay, let me write it more nicer. Okay, so it says win at least 1 bid. That means probability X is 1, or probability X is 2, or probability X is 3, or probability X is 4. So the answer to this question, this is the event, win at least one bid. So this whole thing here simply means probability x is 4 plus probability x is 3 plus probability x is 2 plus probability x is 1. Okay, now remember we talked that in the earlier video session on discrete random variables about that the sum of all these probabilities, that probability x is 0, all of the sum is 1. So I'm going to use this idea to get my answers here. So what does that mean? This means probability x is 0 plus probability x is 1 plus probability x is 2 plus probability x is 3 plus probability x is 4 is 1. That's the definition. We are talking about the probability distribution. Now, what is we looking for? We're looking for this, the last 4. So this one is what? Probability x is 1 plus probability x is 2 plus probability x is 3 plus probability x is 4, simple algebra, 1 minus probability x is 0. So in order to find, those probabilities for 4 of them, I can just make my life simple and say, hey, we can write this as 1 minus probability x is 0. So we just have to do one probability. So in other words, 1 minus binom PDF, the number is 4, 0.25, and 0, which is 1 minus, let's take the calculator. So second and fourth. Yeah, you'll have to keep on doing that again and again. Now the trials are 4, probability of success 0.25, this value is 0. Then click on paste, enter. You get 0.31640625 or 3164. So when you do 1 minus 0.3164, I'm just taking 4 decimal places. What do we get? 0.6836. This is the answer. Okay, remember we talked about mean and standard deviation of a random variable? So keeping that in perspective, we will also now look at what is the mean and standard deviation of a binomial random variable. So, if x is a binomial random variable with parameters n and p, mean is very simple. It is simply n times p, number of the trials times the probability of success. And the standard deviation is given by this formula. So just go ahead, guys. Remember these two, and we have already talked about how to use this. So what I'm going to do is I'm going to show you how to use this example, an example which uses binom CDF. We have done a lot of practice of binom PDFs. Okay, let's do an example here. So we have a lucky Larry. Well, lucky Larry randomly guesses at 10 questions on a multiple choice quiz where every question has 5 possible responses. We would like to know the chance he gets at least a B. That means probability, chances probability that he gets a B is that the number of questions he gets them correct. So this X is number of correct questions. That's a random variable. So this X is at least a B. B means what? 80%. So what is 80% of 10 questions? 8. So at least a B means X greater than equal to 8. Now remember, this X is a binomial random variable because there are only two choices, getting correct or incorrect. And then every question has equal probability of success, which is only one possible correct answer out of 5. So probability of success is 0.2, which is 1 over 5. So let's write that down. So n is 10, and probability p is 0.2, which is basically equal to 1/5. Okay, so probability x is greater than or equal to 8. That means either x is 8, or x is 9, or x is 10. Now, once again, either I have to find 3 binom PDFs, or I can do and make my life simple by using binom CDF. So I'm going to show you how to use this one. Now, if you recollect in a previous example, so I'm just going to do a theory over here. We said the probability, the sum, remember, oops, okay. The sum of all the probabilities where this x can take values from, because x is a random variable, remember, a binom with 10 and 0.2. So what are the values your x can take? It can get 10 questions correct, 9 correct, 8 correct, ... 2 correct, 1 correct, or none correct. When you sum all these probabilities, it is 1. Okay? So, which just means is probability x is 0 plus x is 1. And I'm not going to write the rest, but you get it. Probability x is 7, and then x is 8, 9, and x is 10 is 1. Now we are looking at x, 8, 9, and 10. So probability when x is 8 plus probability when x is 9 plus probability when x is 10 is what? Is 1 minus probability x is 0. So let's put them in one bracket. X is 1, ... x is 7. Now, so there's a thing is like, how do I find this? I'm not going to find these 8 of them, x equal to 0, 1, and 7. But we have got this beautiful formula, which is called binom CDF. If you're starting from the very beginning until the end, at some point in the middle, this is going to be binom CDF. N is what the parameter is 10. Probability of success 0.2 and 7. That means probability x is less than or equal to 7. That's what literally it means. So when you plug that, you get 1 minus. So let's go ahead and do the math here. So second was ... go to binom CDF, enter. Now trials are what? There are 10 trials, that is 10. Lucky Larry is answering the questions. Probability of success is 0.2. We're looking at the x value, that means 7. Paste, click, take it there, and click enter. You get 0.999220736. Okay. So 1 minus 0. How many nines? 4 nines. 220736. And that's going to be 0. How many zeros? I think 4 zeros. Yeah, it seems like that. So 4 zeros. 7792. So that's the answer. That's the answer here. So this answer is just using binom CDF 0.407792. Now, the possibility, what is the chance he fails the quiz? Failing the quiz means that you're getting less than 60%. So, failing the quiz simply means probability x is 0, that or x is 1, or x is 2, ... or x is 5. In this scenario, straightforward binom CDF. because it is all values you have to count. So cumulative distribution, this is cumulative distribution, CD here. Okay, it's accumulating here. So this is, n is what, 10, 0.2, and 5. And when you plug that in your calculators, second was click on Binom CDF, enter. So the 10 to change the x value to 5 here. Click on paste. You get 0.993630, all that numbers. So we get 0.99363. So if you want a 0, you can put 1, 6, or okay. So now let's look at the mean and standard deviation. So the mean, or the expected number of these questions Larry gets correct, the formula is n times p, which is 10 times 0.2, which is 2. What's the standard deviation of this number of questions Larry gets correct? It's square root of n times p times 1 minus p, square root of 10 times 0.2 times 1 minus 0.2, which is 10 times 0.2 times 0.8. So let's do the math here, guys. So the answer is 1.264 something. Okay. Now, there's a relationship between the binomial distributions and a normal distribution. What it simply says is that if we here the questions were 10, suppose we had 100 questions, sometimes you have exams which are longer, and every question has 5 possible choices. And how does increasing the number, the question here is how does increasing the number affects the distribution? What we notice is when n is very large, this binomial distribution becomes more like a bell-shaped curve, and we can use the empirical rule and the empirical use and the normal distribution to approximate a binomial distribution. So what simply this says is that if you have a very large number of trials and your distribution is binomial, then we can approximate it with the by normal distributions, and we can use empirical rules, and our life would be very easy. Okay, we are done with this chapter, guys. So have a great time, and thank you.